In this demonstration, we shall see one way to program in an algorithm for finding the confidence interval using the F distribution. Now, this particular confidence interval will be for the ratio of variances. So we're going to go ahead and do program. We'll go over to new, and we will type in F-I-N-T-V-L for F interval. We're going to go to program, go over to I/O for input, and we're going to ask the user to input in some information. Now, what I'm going to do here is I'm going to have the calculator, I'm going to use the calculator's kind of statistic symbols in my program. So I'm going to go to VARs, and then I'm going to select option 5 for statistics. And then I'm going to select option 3 for SX. This is the calculator's notation for standard deviation for a group. So I'm going to use SX for telling the user to input in standard deviation for a group. So I'm going to select option 3. And then I'm going to type in 1 for the first group. I'm going to do a colon. And I'm going to go ahead and close these double quotes. Then I'm going to do a comma, and I'm going to store this value as S. Then I'm going to hit program, go to I/O, and input, double quotes. And then again, I'm going to hit VARs to bring up this menu. And then I'm going to hit 5 for statistics. And I'm going to select the first option, N. I'm going to select for the sample size. So I just hit enter, then I type in a 1 for the first group's sample size. And I do a colon, and then double quotes again, and I'm going to store this value as N. Then I'm going to kind of repeat this again. Go to program, go over to I/O for input, double quotes, go to VARs, stats, SX, type in 2 for the second group standard deviation, colon, and the double quotes, then a comma, and then I'm going to store that value as T. Then we go back to program, I/O, input, open the double quotes, go to VARs, statistics, N, type in 2 for the second group's sample size, colon, and the double quotes. I'm going to store that value with a comma and then M. Now the last thing I need from the user is to input in the confidence level. So again, I go program, I/O input, double quotes, and I'm going to just type in the characters C, and then I'm going to put a minus sign for a hyphen, and I'm going to type in the word level, L-E-V-E-L. And after I get that typed, I'm going to do another colon and the double quotes, and I'm going to put a comma, and then I'm going to go ahead and store that value as C. Now, in order for me to get my critical values for my confidence interval, I need to do 1 minus C, all in parentheses, and then divide that difference by 2. I'm going to store that value as A. Now the next thing I'm going to do is I'm going to go to Math, I'm going to hit the Math button, and I'm going to go up 1, and I'm going to call up this solve command here. So when I do that, now I'm going to go ahead and go to second VARs for the distribution menu. And I'm going to go ahead and hit up 1. And then I'm going to select option 0 for FCDF. And then for the lower bound, I'll put 0 in. The F distribution is only defined for non-negative input, so the lower bound cannot be anything less than 0. Then I'm going to give it a variable, x, to solve for. Then my degrees of freedom for the numerator is going to be the sample size of the first group minus 1. The degrees of freedom for the denominator are going to be the sample size for the second group minus 1. And then I'm going to paste that back into my program. Now, that gives me the area under the F distribution with those degrees of freedom between 0 and x. So now I'm going to subtract off that a value that I just calculated previously. Now the solve command says give me the equation to solve that's already set equal to 0, tell me the variable to solve for, and then tell me a starting point to begin the algorithm. The solve program uses a variation of the Newton's method that you study in calculus. So we're going to do a comma that tells the solve command that this is the equation set equal to 0 that we're going to solve for. I'm going to put x in to say solve for x, then I'm going to say start guessing at 0, and then I'm going to close that. And I'm going to store this result as L for the lower critical value. Then I repeat this. I recall the solve command. I go back under distributions, back under FCDF. The lower bound will be 0. The upper bound will be x. The degrees of freedom for the numerator, again, will be n minus 1. The degrees of freedom for the denominator, again, will be m minus 1. Then I'm going to paste that back in. And this time I'm going to subtract 1 minus a. This will give me the right critical value. And I'm going to put 1 minus a in parentheses, so it's subtracting that difference. Then I'm going to do a comma, x, the variable I need to solve for, comma, 0, the starting point of my algorithm, end that solve command, and store this as the variable r for right critical value. Then I go over to Program, I/O, and Display, because I'm going to display the lower bound for the confidence interval. So I'm going to type in C, then I'm going to hit the minus sign, and then I'm going to type in the word lower, L-O-W-E-R. And then I'll put a colon, and then I'll close off those double quotes. And then I'm going to do a comma, and this time I'm going to give it the formula for the lower bound of the F interval, which in this case is S squared, standard deviation from the first group, divided by the standard deviation of the second group, t squared in our algorithm, times the right critical value. Then I'm going to close that. Then I'm going to go back to Program I/O, Display. I'm going to do another double quote, and this time I want the upper bound on my confidence interval. So that's going to be C, then the minus sign for a hyphen, and then I'm going to type in the word upper, U-P-P-E-R. I'm going to put a colon and the double quotes. I'm going to get a comma, and this time I'm going to do the formula for the upper bound of the confidence interval, which in this case will be S squared divided by the quantity t squared times L. And then I'll close that quantity in the denominator. And this is one way to program in the F interval, but we need to test this to make sure that it is working properly. So what we're going to do is we're going to come up with an example, and in this example we're going to suppose we wish to find a 90% confidence interval for the ratio of the population variance, where N1 is 21 and N2 is 11, and S1 is 2.34 and S2 is 4.33. Now in a separate calculation we find that the answer should be, the lower bound should be about 0.153 and the upper bound should be about 0.6857. Now remember that when you are comparing results there may be some rounding issues, especially when you're using textbooks. So just be aware that we may not get exactly these numbers, but we should be getting something really close to it. So we're going to go ahead and quit out of here. And we'll go ahead and call the program. I'll do alpha F to bring up the F interval. And then I'm going to type in the standard deviation of the first group, which we're told is 2.34. And then I'm going to do the sample size of the first group, which we're told is 21. Then the standard deviation for the second group, which is 4.33. And then the sample size for the second group, which we're told is 11. And then I'm going to let this algorithm run after I put the confidence interval at 0.90 or 90%. So we'll let it run for a few minutes, and hopefully we will see results that are consistent with what we should be getting. And we do. We actually do see this. So C lower is about 0.10528, which would be about 0.1053. And C upper is calculated to be 0.68569, which is pretty close to 0.6857. So we feel pretty confident that this algorithm is working satisfactorily. And this is one way to program in finding the confidence interval for F distribution, finding confidence intervals for the ratio of population variances using the F distribution.